Alrighty, test next week, and here's what you can expect on it. You don't have any problems doing your own today, just note taking on what you need to know for the test. Determine whether each function is exponential growth or decay. So, the way to determine that is just make a table and just insert 0, 1, 2. And I'm just going to put 0 in for the x, okay? So to find the y, we'll just punch in 2 times 4. Now the power button's right here to the power of 0, and that's going to be 2. The reason that's 2 is because that right there, anything to the 0 power is 1, and then 2 times 1 is going to be 2. Okay? Then just click up. Now instead of a 0 power, we want a 1 power. That's 4 times 2 is 8. So the first power, we're going to go second power. So 4 times itself, that would be 16 times 2 is 32. Now with that table, I can tell if it's growth or decay. It goes from 2 to 8 to 32. That's growth. Okay, and my next problem, same idea. And you could keep going with that, but really 0, 1, 2 does the job. Okay, so we have 3 times 0.25 and hit your power button and then 0. Now remember we said anything to the 0 is 1. If I take 3 times 1, it's going to be 3. I click up. 0.75. Okay, then instead of a first power, I want a second power. 0.1875. Now that's going down, so that's known as decay. The reason why it's growth here is because if I take a number times 4, it grows, but if I take a number times 0.25, 0.25 is less than 1. Okay, so that's going to be decay. Okay, so then I'll take 25. AB, actually get rid of the 2 and just put 5 sevenths, please. 5 sevenths, okay? So 5 ABC 7 times 7 ABC 5. Oh, you'll need to put a fraction. Sorry, you need to put a parentheses around your fraction. Okay, that's to the power. So parentheses 7 ABC 5 to the power of, first the power of 0, 5 over 7. Then to the power of 1. Okay, I got 1. Then to the power of 2. 1 and 2/5. Okay, that's getting bigger. Okay, I know those are fractions, but it's growth. The reason why is because if you have 7 over 5, that's greater than 1. Because see, if I divide 7 by 5, that's bigger than 1, 1.4. Okay, then my next one. So I go 0.5 times parentheses 1 ABC 4 to the power of 0. That's going to be 0.5. Then to the power of 1, that's going to be 0.125. Then to the power of 2, 0.03125. So that's getting smaller. It goes from a half to really small decimals. So that is decay. Okay, because when you take something times 1/4, 1/4 is less than 1 whole. Okay, 7 over 5 is bigger than 1 whole. So that's why that's growth and that's decay. Okay, so that's that one. Now there is one graph you're going to do. Okay. Graph the function y equals 2 to the power of x. Remember, it's not 2 times x, it's 2 to the x power. Okay, so making that little upside down v tells me we have an x power. So you're graphing an exponent function. So you're going to put numbers, integers 2 through -2 in. That just gives me a wider. There's also that line that you can't cross, known as the asymptote. You start with that as 0. Okay. ASY, if you want to abbreviate it. Okay, so I just take 2. First off, let's just take 2 to the second power. Okay, 4. Now, 2 to the negative second power is just the reciprocal of 4. We'll just make it 1/4. Okay. Actually, hold on here. That's not how I told you to do this. Okay. Trying to think of how I explained it. Yeah, here's what I had you do. Just worry about that and just go 2 to the first. That would be 2. Anything to the 0 is 1. And then just go 2 to the power of -1. Now you're going to get a decimal. And then to the negative second. Okay, so 0.25. Now we leave our x's, but we have to add 3 to all of the y's and then add it to the asymptote because there's an operation of +3. So I just take 2 to these powers here, and then after I get all the results, I just add 3, and then I have to add 3 to the asymptote. So 4 plus 3 is 7, 2 plus 3 is 5, 1 plus 3 is 3, 0.5 plus 3 is 3.5, 0.25 plus 3 is 3.25, and 0 plus 3 gives me 3. Okay, so 2, 7. By the way, your asymptote's 3, so what you do is go to 3 on the y-axis and you make this line here, and all points are to that side. You'll never cross that. So 2, 7. 1, 2, 3, 4, 5, 6, 7. Okay. 1, 5. 1, 2, 3, 4, 5. 0, 3. Whoops, sorry, I messed that up right there. Okay. I'm supposed to be adding 3. 4 plus 3 is 7. 2 plus 3 is 5. 1 plus 3 is going to be 4. These are 4s. Okay. I misdid that. So 0, 4. And all you do with the rest of the points is you just get closer to the line. Sneak closer against it. At the end, you're running kind of parallel to it. Okay. Really close to it, but parallel. Okay. Maybe didn't explain that the greatest, but we'll work more on it again. Okay, write each equation in logarithm form. Here's what you do. You write the word log on this side. Your little power is going to be over here by itself. Okay. The log's base is going to be the 5. So it's log base 5 equals 3. And then I put the 125 right there. And that's how you write your own logarithm equation. Okay, so write the word log. The little -3 comes over here. The 10's right there. Then I put 0.001 behind it. Okay, that's all you do on those. Okay. Okay, evaluate each logarithm. Remember, the first thing you want to figure out how many sixes it takes to multiply to 216. Okay, that's the first order. That's 36. How about that? Okay, 216, so it takes 3 of them. Okay. So we're going to, base is 5, so that's what I'm multiplying to get to 625. 25. Times 5. 625. Okay, so that would be 4. Okay, so log base 11 of 121. Trying to get it equal to 120. The base is 11. The 11's what you can't multiply anything but 11. So 11 times 11, I think, is 121. So it takes 2 of them. Now, if you have 1 over the top of a whole number on a logarithm, if you put a negative, then you can just do 27. Okay, you don't have to do 1 over it, as long as you put a negative, because a negative, so 9, that's 27, so 1, 2, 3, so it'd be -3. Okay, now you're solving each equation. You're going to do the same thing. Okay, you see the x on these is in the power. I also put a parentheses around that one right there. Okay, and I should put a parentheses here. Sorry, I forgot about that. They'll be that way when you would work on your own or take a test. So the first thing I do is I line my 2x equals. Then my first thing is try to find how many 3's it takes to multiply to 81. That's what the power is equal to. So that's 9. That's 27. That's 81. So I'm there. 1, 2, 3, 4. So the expression 2x equals 4. If you want to put a equals 4 there, you can. And you just divide by 2 and you have your answer. X is 2. Okay. Next thing, I need to figure out what my power is equal to. So my first thing I'm going to do is multiply 3's out to get to 24. 9, 27, I'm over the line. So if that doesn't work, then to find what the exponent equals, I have to do my log over log. Okay? And the 3 is on bottom, and the 24 is on top. Okay? So I take log 24 divided by log 3. 2.89. So x minus 1 equals 2.89. Plus 1, you get 3.89. Okay, then my 1 here, I need to get rid of this log, okay? So I need to get this out of logarithm form. So whatever's in the parentheses, I put by itself, and then over here I put a base of 10, and I put a second power. Okay, now I can solve it. 10 to the second, x is equal to 10 to the second power, so I just figure out what 10 times itself would be, and that's 100. Okay, next one I gave you a little hint in the corner, okay? The hint says ln, but before you worry about the ln, you got to eliminate this 2. So divide by 2, and you get 8. Now, after that's done, then I can go to my ln, because you remember from yesterday, that eliminates the e, and now I just have 3x. And over here I find ln 8, so 2.08. And I divide by 3. 2.08 divided by 3 is going to be 0.69. Okay, then the story problems are going to be kind of easy. I would use the table, okay? I deposit $300 in a savings account that earns 2% interest each year. That means plus 2%. How much will be in the account after 5 years? So I would line up a table. X is the years, Y is the money. Okay, you always put 0, and then you start with $300. Now after the first year, you have increased it by 2%, so you need to take 100%, add 2%, which is 102%, and then multiply by 1.02, and that's how much you'll have after the first year. Okay, $306. Now in the second year, I multiply by 1.02 again. $312.12. Okay, multiply by 1.02 again, and that'll find how much I have after 3 years. $318.36. Remember, I just have to find 5 years, okay? That's all I have to get to, so this way works pretty good, okay? $324.73. $331.22. Okay, that's your answer right there. You want to know how much would be in after 5 years, so it's that one right there, $331.22. Okay, number 10. You deposit $500 in a bank account that earns 3% interest each year. How many years will it take the account to reach $700? Okay. All right, so let's go into our exponent, or our table. A little bit different on this one. Okay, so 0, you have $500 to start with. Remember, you're trying to get to 700, trying to figure out how many years. So I take 100% and add 3%, and that'll be 103%. So if I multiply by, move the decimal, 1.03, that takes me to what is in my account. 500 times 1.03, I got 515. Times 1.03, 530.45. $546.36. Remember, I got to get to 700. It's not going to take maybe as long as you think. Okay, so 1.03. 562.75. Because the more we get, then it starts going up a lot quicker. Okay, 579.64. 597.03. Okay, 614.94. 633.39. 652.39. Persevere here. 671.96. So we're getting closer to $700. 692.12. I think the next one's going to do it. Yep, over. Now you're over. Okay. So it would take 12 years to get $700.